Good day. Today we'll be discussing on the Bohr's model of hydrogen atom. Niels Bohr studied the light produced when atoms were excited by heat or electricity, that is in 1913. Rutherford's model couldn't explain why unique colors were obtained by atoms of different elements. And it was Bohr who proposed that electrons are in orbits, and when excited, these electrons jump to a higher orbit. When they fall back to the original state, they give off light. And that is why you would see different colors of each element. So in Bohr's model, electrons orbit the nucleus like planets orbit the sun. As you can see in the figure, you have the nucleus at the center. You have 6 protons and 6 neutrons. And along its orbit, you have the electrons. Now each orbit can hold a specific maximum number of electrons. Electrons fill orbits closest to the nucleus first. So in this table, say you have the first orbit, so the maximum number of electrons is 2. So following the formula for the maximum number of electrons, which is 2 times n squared, where n is your orbit. And so, for the second orbit, you have the maximum number of electrons, which is 8. And for the third orbit, you have the maximum number of electrons, which is 18. For the fourth orbit, you have 32. For the fifth orbit, you have 50. So we will be using this periodic table of the elements. As you can see in this figure, you have the larger part for representation. You have the iron, which has its symbol Fe, and on its upper right you will see 26, which is the atomic number, and on its left you will see the atomic mass. But usually the atomic mass is the atomic mass of an element is also located at its lower part of the element. So just like what I've said, each orbit can hold a specific maximum number of electrons. Say you have a potassium and you have an atomic number of 19, and then you have its atomic mass of 39. And so you have, since you have 19 atomic number, so you will also have 19 protons and 20 neutrons. So another example is fluorine, which has an atomic number of 9 and atomic mass of 19. And so the number of protons is 9. The number of protons is equal to the number of electrons, so you would also get 9. And the number of neutrons is obtained by the difference of the atomic mass and the number of protons. So if you have the atomic mass of the fluorine, which is 19, minus 2 the number of protons, which is 9, then you will get 10. So the number of of neutrons for the fluorine is 10. So you have 9 protons, 9 electrons, and 10 neutrons. Now, how many electrons can fit in the first orbit? So as you can see, it's 2 because the maximum number, again, the maximum number of electrons that can fit in the first orbit is 2. So if you have 9 electrons, 9 minus 2, you will get 7. So how many electrons are left? So you only have 7 electrons left in the fluorine electrons. So up to how many electrons can fit in the second orbit? So again, you have 8. And so if we arrange that, you have 2 at its first orbit, and then you arrange the 7 electrons on its second orbit. Now you try these elements like the hydrogen and magnesium. For the hydrogen, it has 1 proton and 0 neutron. And so since it has 1 proton, then it also has 1 electron. How about magnesium? You have 12 protons and 12 neutrons. So you have at its first orbit, you have 2, and on its second orbit, you have 8. So 8 plus 2 is 10. And so you only, what's left is only 2. And that is why on its third orbit, we place 2. So all in all, you have 12 electrons. So I hope you enjoy watching this video, and the part 2 of this video will be posted probably next week. So see you next week. Bye, and thank you for watching.